That's all the power?
Okay. No.
No more power?
I have some peanut butter honey.
That's not power.
That is protein.
What you got? No, that's okay. That's too nice. Too nice. Alright, did I open this? Yes, I did. Previously on math class, we looked at the names of the parts of the circle. That's where we finished last time. Correct?
Yeah.
Yes? Yeah. There's some other names which are not on this diagram, but I think some of you know. For example, what is the name of 2-or? Diameter, very good. And what's the name of the full arc? Circumference, yes, very good. No other terms necessary here. Okay. In physics, we use what's called a radian, which we talked about last time as well. And do you remember the angle? 57.3 is a radian. I'm sorry. 180 over pi to be exact. So a radian is a pretty big unit. It's important because it's the unit that's used in the formulas for circles, which we're going to have a look at today. Okay. So, new slide now. Here's something very, very simple I would like you to try and do for me. Convert these two angles for me. What the heck is that? What is that?
The thing.
What?
The thing.
What thing?
The thing.
What thing? What on earth is that?
It's the thing. The thing. The thing. And the water comes.
Oh, hose.
The thing.
Thing. The hose. Alright, have you done this? Have you done both parts?
No.
Lee, you done this? Where's Omar?
They're here. Everyone's here. Not here, that's right now.
Well, now it's interesting.
3 minutes.
Well, what happened to you two?
You can blame me.
What happened? Good reason?
I took him to the other building.
Oh. Wait, can you get by? Come on, you might have to move.
No, it's okay.
What's happening? You're late for class. What's happening, Omar?
What happened?
Who else am I missing?
Nadir.
Oh, yeah.
And
Who?
Yusuf.
Oh, Yusuf, the guy who knows everything. Yeah. And who else?
He was here.
And who else? Yusuf and Nadir, is this?
Yeah.
Is there someone else?
Yeah, we look few than just two missing.
Yeah,
No.
we're 9.
Okay.
How can you convert?
Yeah, I'm going to do it now. Okay. So firstly, 0.25 radians.
No.
What?
That's fine.
0.25 times 1 radian. But 1 radian I said was 57.3 degrees. So 57.3 times 0.25, and we get 14.33 degrees. Part B, 30 degrees into radians. So 30 degrees is 30 times 1 degree. How big is a degree? Well, I said that 57.3 degrees equals a radian. So that means 1 degree is 1 over 57.3 radians. So this is 30 times 1 over 57.3 radians.
P over 6.
What did you get?
P over 6.
B?
P.
P?
P.
Pi!
Yeah.
0.524. Dude, you've only been here 10 seconds. You can't ask questions yet. You haven't been in the class long enough. 5, 2, 4 radians.
Can I write pi over 6?
Yes, if you like. Now, have you been in the class long enough to understand what's going on? You don't even have your notebook out yet. Once you're ready for class, then you can participate.
I got my answer.
Right, did you write this down? Yep.
Why is it times 1 degree?
Well, it's 30 degrees, so I wanted to pull the degree out separately, you know, like it was a meter or something. Okay. Do you have this? Continue. We've seen two types of motion so far in physics. The SUVAT motion in one dimension, like a car moving on a road. The SUVAT motion in 2 dimensions, like a projectile fired through the air. Now we will look at a new type of motion in 2 dimensions, motion in a circle. So, firstly, what makes motion in a circle? If an object is traveling in a circle, it is because there's a force acting on the object which is perpendicular to the velocity and towards the center of the circle. So, in other words, if something is moving in a circle, it's because there's a force acting on it towards the center of the circle, and this force is perpendicular to the velocity. This is what makes circular motion.
What force is perpendicular to the velocity?
The force that acts towards the center is perpendicular to the velocity.
Why not on the side? Why not the V is on the side?
That's fine too.
That's okay.
Yeah, it just means the motion will be this way instead of this way. This one is anti, and this one is clock. Yeah. This definition I sometimes ask in the exam, so you do need this for the exam. Oh my goodness, it must be my birthday. You're writing something down in class. I feel so touched and honoured.
It's Lee's birthday.
Is it? And he's writing. Oh, great.
We sang a happy birthday in Chinese.
Great. How old are you, Lee? 9? 19. It makes more sense.
If there is a force acting on an object, let's say it's a cube, and then there's a force that's on two sides of the cube. Which one will it be going in circles?
On two sides of the cube? How so?
Like,
Use your wallet,
this
yeah?
is a cube.
Yeah.
It's blasting gas from here and from here. And then there's an engine from here and
Yeah.
an engine from here. Would it be going in a circle? Or would
Yes,
it just
yes.
move in a resulting vector and go straight?
Yes, you can make it go in a circle. You need one jet to get it up to the right V,
Yeah.
and then deactivate it, and then once it's traveling at that velocity, have the other jet activate. But
You'll have to activate and close to maintain the velocity.
I don't know. I'm sure it's possible. These are things I don't think about on my journey on the bus. You need to ask me physics questions I might think about when I'm on the bus. Space engines, no. Okay, do you have this? Yep. So a little bit of vocabulary. Centripetal force is a type of force that acts on any body that revolves around a center. This force keeps the body moving in a circle. It's always directed towards the center. In other words, this force here is called the centripetal force. Centripetal. Or I suppose you could pronounce it centripetal. That's okay too. Is this easier to say? Yeah? Continue? No, not yet. Did you write this down, Lee? So where did Yusuf go? Yeah, well, why? Is he? But I'm sick. How sick did he look?
I didn't know that you were sick when I saw him.
Too sick, you say? He was saying, no, I must go to physics. And you were saying, no, look how sick you are. You must go home right now. Okay, you got this? But because F equals ma, and for example, if m was 1 kilogram, then F would equal A. Basically what I'm saying is, this result should not surprise you. That centripetal acceleration is the acceleration that makes it move in a circle. And it's also directed towards the center. Now this makes perfect sense. If F equals ma, then this vector here, the F, is the same as ma. In other words, if F is here, A is here as well. So you can say the F is towards the center, but you are also able to say the A is towards the center, because F equals ma. And in fact, if m equals 1, then they're actually the same thing anyway. So another piece of vocabulary is centripetal acceleration. Yeah? Oh yeah, I have your homeworks here, thank you. So Andrew, hand that to Andrew. Wong, there you are, pass that to Wong. Lee, for Wong. Who's friends with Omar? Oh no, sorry, Omar's here, sorry. Omar.
Even when he's here?
Sorry. Faisal, I meant to say, who's friends with Yusuf? Does anyone live with Yusuf? Are you friends with Yusuf? Like, would you see him after school?
No, tomorrow.
See him tomorrow? Can I give you this to give to him?
Yeah.
Yeah? Give that to my unforgettable Omar, please. Unforgettable. All I did was to look at your coursework. I'm happy with the effort people are putting in. We'll see what the test is like on Friday.
Can we ask for something?
What do you mean? Yeah? What do you want?
Try not to make it as long as enough.
I won't make any promises, but I'll see what I can do.
For this homework, I couldn't finish the questions with this.
That's
Now-
okay, but you
now
tried.
but now that I know them, could I solve them?
Absolutely, and absolutely, no problem. When you have them finished, just let me know. Okay. Continue.
No.
You notice it's the same except I replace force with acceleration. Yeah, whatever. I'm not in any rush. We have class tomorrow.
But how can I do the
Oh, I'll worry about you later. Why are you doing the Lithuania test?
I don't know.
But the Lithuania test has biology.
Yeah?
You haven't studied biology.
Yeah.
Whose idea was this?
Dr. Lorraine.
Hey.
Why is
And did
that
you-
physics?
Yeah, it doesn't have physics, I don't think.
Ah,
I don't know. Maybe it does.
no, it's not.
If we have a question,
So you're doing a biology test on Friday
Yeah.
instead of a physics test.
if we have a question about the homework, could we ask?
Yes, you can. I don't know if we're on. I'm a bit worried about you.
But it's not an MA thing.
It is an exam.
Really? Next one.
Oh, it's not an exam, are you sure? Yes, Lithuanian exam.
But which exam?
Biology and chemistry.
Both together?
Yeah.
Ah, nice.
No, not nice. It's not nice. All right.
What happened?
Yeah, I don't know, Ron.
I test we do today, but you not agree.
I know, so now I have to give you the test another time. I'll talk to you later about it. Okay. Right, some more terms. Angular velocity, omega, is the rate of change of the angle with respect to time. And the units, of course, are radians per second. So this measures how quickly the angle is changing. For example, 1 radian per second would mean 57.3 degrees per second of an angle change. So for example, look here, imagine this is moving in a circle. So if in 1 second it moves 57.3, that's 1 radiant in 1 second. So that's 1 radiant per second. That's the angular velocity. It's how quick the angle is changing. Yeah. Mm-hmm.
Wouldn't it change depending on the diameter of the circle?
No, the angular velocity doesn't care about the diameter or the radius, just the angle. You are thinking of something else.
Like, let's say,
No, shh. Listen to me. You are thinking of velocity, and the velocity will change depending on the diameter. A greater diameter would mean a faster moving object. But the angular velocity does not depend on the diameter, just on the angle and how quickly the angle changes per second.
so if we have the same angular velocity,
Yes.
an object will go in a full circle in the
Yes.
same time if the
Yes.
angular velocity
It's the
regardless
same,
is
yes.
that?
Believe it.
How quickly will change in 1 second?
Okay, next definition. The next definition is the periodic time. What do you think this is?
The time taken to finish a circle.
Yeah, the time taken for one complete orbit. Of course, the units are
Second.
seconds. If t is 2, then it'll take 2 seconds to complete an orbit. Yes? Yes? Okay. Next, frequency. The unit per second is also called, does anyone know?
F
Mm,
and the unit.
Period.
What?
Hertz.
Called a hertz. So 1 hertz is just 1 per second. So per second is also called a hertz. You might want to note that.
But the letter we write is F, right?
Yes. In
For
time.
what
No.
symbol?
For what?
Frequency.
Oh, I haven't said it yet. It's going to be an F, but we'll come to that. I'm just talking about the unit right now. You got this? Yep. Okay. The frequency F is the number of orbits in 1 second, and the unit is per S. So, if F equals 2 hertz, then 2 orbits are completed in 1 second, and if F equals 0.5 hertz, then only half an orbit is completed in 1 second. You had the ESAP lesson on circular motion,
Yeah.
so you have all the vocabulary for that. Rotation, revolution. Is the ESAP useful for your vocabulary? Why not? Too much? Too little? Too easy? Too hard?
I can't understand.
Too hard. Okay. You need it easier?
Wait, what ESIP?
ESAP physics.
Ah,
The one
so
you have
it's
on the side.
Isabel.
Isabel, yeah.
Okay.
Alright, good. Continue. We have formulas for circular motion, just like for SUVAT. So the first formula is pretty simple. If we know the frequency, we can know the time. And likewise, if we know the time, then we can know the frequency. The time equals 1 over F. First formula. Second formula. If we know the time, then we can know the omega, or vice versa. If we know the omega, we can know the time. Omega is 2 pi over t. Number 3. The velocity or rather I should say the speed. The speed is omega multiplied by the radius r. The linear speed is omega r. The acceleration is v squared over r. V squared over r is the acceleration. And that's it. That's the 4 key formulas minimum you need for circular motion. There are others before you say anything.
No, it's about the third one.
Yes?
If we rearrange it to make omega equals v over
Yeah?
r, then the radius will affect the angular velocity.
Yes, but the v is also changed in such a way that the omega stays the same. So for example, if omega equals v over r, and the omega stays the same, if you increase the r, then the v is forced to increase to keep the omega the same. So I wasn't lying to you earlier. I don't know if you're sitting there thinking, there's that liar Stephen again, telling me physics lies. I'll catch him one of these days. You just wait and see, Stephen. Is that what you're thinking, or? No?
Not really.
No, I mean, see, he never said no. He said not really, which means, kinda, maybe. Yeah. Alright. Do you got these formulas? Yeah? Okay. Let's have a look at an example using these formulas. So, this one actually doesn't really need the formula. A CD spins at 500 RPM. What is the omega? So what is RPM?
That's per minute.
So again?
That's per minute.
Yeah, but rotations per minute. So, if you have 500 rotations per minute, that is 500 rotations per 60 seconds. So that is 500 divided by 60 rotations per second. But how much of an angle change is a rotation? 360 degrees in total. So that's 500 over 60 times 360. But 360 is not the unit we should use. We should use radians, not degrees. Does anyone know the angle for one rotation in radians?
160 divided by 5.
You could work it out. It comes in about 6.2830. So in other words, it's about 2 pi is a rotation per second. But per second, radians per second. Radians per second. So the omega is 500 over 60 times 2 pi, which equals something, and the unit is radians per second. Could someone tell me this, please?
Uh, 52.4.
Why?
No.
52.4.
The desk.
Yeah.
No, hit SD.
52.4.
52.4.
But why is it 2 pi?
Yeah. If you recall, I said 1 radiant equals to 57 degrees, which is about pi over 180, or is exactly pi over 180. So that actually means
180 over.
I'm sorry. Thank you. 180 over pi. So that means pi radiant is 180 degrees. So that means 2 pi radians is 360 degrees. So one rotation is 2 pi radians of an angle change. Okay, are we happy with that one as a first example of circular motion? Go for it, Andrew. Your question is?
Do you have a strike on the 500?
No, that's just me being tired.
Oh, okay.
Okay. Did you write that down? Go on, did you write that down? What's wrong?
Why you put the 2 pi in?
I know what's wrong.
Um,
You didn't get any flowers today.
well,
All these boys, and not one of them bought you flowers.
They both
Disgraceful. You should be ashamed of yourself.
You didn't buy her one either.
That's not my responsibility, that's yours. You're her peers, not me. Huh? What? You have a question about this? What's your question?
why 2 pi?
Oh, I just explained it to him over there, where the 2 pi comes from.
No.
No, yes?
That.
Yes, what?
Why you put 2 pi in there, not
Here?
yeah?
Because the or, what does the or stand for?
But
Radius.
omega is the
Angle.
angular
Yeah, this
velocity.
or here stands for rotation. You remember this word in ESAP, rotation?
No.
She drew it, rotation and revolve. Remember?
Oh, come on, it was like last
Rotation.
week, wasn't it?
And she was telling us like, this is
Easy to forget.
It is easy to forget. The or means rotation, and one rotation is 2 pi radian.
Oh.
So this or, I can change it to 2 pi radian. What?
But the question is asked about the omega.
Yes.
And
So-
that answer is not omega.
It's not?
Doesn't the omega also have 2 pi in the
No. Guys, look! Goodness, I'm dying here. Right, what I'm saying in this question is, this will rotate 500 times in 1 minute.
Oh. So RPM is mean time in
Yes,
1 minute.
yes. Thank goodness. So seriously, where are the flowers?
I don't have. FA.
FA?
Yeah.
What's FA?
Forever.
Very good. I know this cartoon. Internet. Right, continue. The guy with the big
Yeah.
face. Yeah.
with the double chin.
Yeah, and the tear.
Yeah.
Yeah. Ah, classic. All right. Okay. You can write or draw, and then I'll do it. So, a car takes 5 seconds to drive around a roundabout. From. What is roundabout? No problem? Who knows a roundabout? Not everyone. Describe what it
When
is.
you're driving in the car,
Where they
there is
drift,
a circle, and then you go around the circle.
and then there
Ah.
are exits.
Yeah.
On the road.
Yes.
Yeah.
This is a roundabout. And the roundabout is 6 meters radius. I want to know the speed of the car. So let's, can you write this down or draw it, and then I'll do it.
But we want to calculate the speed. Can we take the circumference of the circle and the distance?
You know, I think you can, but it's really not the way we do it in physics. When I gave this question to the biology teacher, that's how he did it. So you don't want to be doing it like a biology teacher. You want to be doing it like a physics student. So I wouldn't do it this way, okay?
Stephen, what was the first question asking us for? A CD spin with 5?
I want to know what the omega is, the angular velocity.
Oh.
Okay, can I do this one now? Let's have a look. So, here's the car, and it's going around the roundabout, and the radius is 6 meters. So the or equals 6, and the time I said is 5 seconds. Okay, what did I want? I want to know the V. Yes? Now, if you think about it, what's the formula for V? Omega or. Do you know the omega?
No.
No. Do you know the or? Yeah, so we know this, but we don't know this. What's the formula for omega? 2 pi over t. Do we know the t?
Yes.
And the 2 pi?
Yes.
And the or. So the answer is 2 pi times 6 over 5. So 2 pi... Huh? Let me double check. 2 pi times 6 divided by 5. And what did you get as a decimal? 7.54 meters per second. As an example of revision of unit conversion, I want everyone to convert this into kilometers per hour. Go. So write this down and give it to me in kilometers per hour. Seems reasonable. I'll have to convert it, but 27, yeah. Let me do a rough estimate in my head. 6 times pi is 18. Ah, no, I'm too tired to do it in my head. Anyone else get an answer?
Convert 7.54, no?
Yeah.
10 to
What did you get?
2.7.
Yeah, what did you get?
27.
So why did you stop?
You know, I'm not criticizing your work or anything.
Yeah.
This is just to clarify something.
Yes.
The meters per second, yeah?
Yeah.
Is there supposed to be a space between M and S?
There should be, absolutely. There should be a space between the M and the S, and no space if it's a prefix. So technically what I wrote was more like milliseconds than meters per second.
So in the exam, if I by mistake you write that.
Couldn't care less.
Not you, but like NCUK.
Oh no, the person who writes the physics exam is very, very, very careful with things like this. Very careful. It'd be very unusual for him to type the exam without the correct spacing in it.
I mean, if I wrote it.
And that's okay, I'm okay with that too.
Yeah?
Yeah. Okay, continue. Yep. Alright. Now, convert this. So, that is 7.54. And I'll put in kilometers per second. And to cancel kilo, I must divide by kilo. Yes? And then, how many seconds do I need for an hour?
3,600.
Now, just be careful, this is meters over seconds, okay? So, I need how many seconds here? 3,600. So on the top I need 3,600. So I get, this is now becomes hours, and this is now become kilometers. So the answer is 7.54 times 3,600 over kilo, which is 1,000, kilometers per hour, which should be 27.14 kilometers per hour. A reasonable number for going around a roundabout. Okay, got that? Continue? Yes? Next. A 10,000 kilogram plane is banking. I'm going to ask this question, and before you answer it, I know banking means the place where the money is. That's not what it means here. Does anyone know what banking means? Can be a bit more precise than that, actually. That's not quite enough. It's a very particular type of motion for the plane.
That's one.
Not quite that.
When they delay your
That is
like this.
that is a consequence of banking. That's banking. Yes, Juan got it.
What?
Banking is when the plane turns on an angle like this. So what happens is the plane is traveling straight, but then when it banks, this is what makes it turn in a circle to keep it around the airport if it's delayed. So banking is a verb that means to tilt. But it only applies to... No, actually that's not true. I was going to say it only applies to planes, but it could... Yeah. Well, no, you can use it for trains as well. And helicopters, yeah. No, anything that leans as it turns, we can say is banking.
Even cars.
Cars don't bank.
But then they do this thing where they go...
Motorbikes bank. Yeah.
Only in the Arab Gulf.
Yeah, I've seen some of those Saudi driving videos. Yeah, I know that in Saudi perhaps the cars bank as they turn. In Ireland they do not. Okay. Motorcycle, helicopter, plane. Some trains are actually built to bank as they turn in the UK.
Roller coasters.
Roller coasters, yeah. The advantage of banking is it makes the turn wear less on the track. So when the train banks, it means that the tracks they wear equally. You see, what happens is if the track doesn't bank, then one of the tracks wears faster than the other one. But by banking, the train puts equal force on both tracks as it turns. So anyway, banking is an important thing in engineering, especially in transportation, and especially for fast-moving objects or heavy objects. Banking is important. So, this 10,000 kilogram plane is banking, and it takes 1 minute to travel in a circle of radius 1 kilometer. What is the centripetal force? Okay. So, I'll draw two pictures. First, from the sky. Here's the plane, and this distance here is 1 kilometer, and the time it takes 60 seconds is the periodic time. So far, so good. Now, next I'm going to look at the plane straight on. So here is the plane here. Like this. So I'm looking at the plane straight on. How many forces are on this plane right now? Well, there's obviously the weight. 10,000 G.
The force towards the
Five.
center of the circle.
Not quite, huh? No, not that many.
There's the drag.
We'll ignore drag. Yeah.
Yeah. 1 up.
Yes, but which direction up?
There's a centripetal force.
Yeah, now we have to be very, very careful here. Listen very carefully to me. Listen very carefully to me. Listening? Centripetal force is never caused by motion in a circle. You must have some force that becomes centripetal force. So, my point is, if this is moving in a circle, it's so wrong to say this makes a centripetal force. You don't say it like this. If this is moving in a circle, my hand has become the centripetal force. Okay? So we should not say there's a centripetal force, because that's wrong to say it like this. One of the forces have become the centripetal force. So which force has become that? Well, it's not the weight. Impossible. That's not going to make it.
Uplift.
Yeah, there's a force here called the lift. This is what makes the plane move up. But because the plane is banking, what has happened is that this lift force has a vertical and a horizontal. We'll call it Lx and Ly. This has become a centripetal force. Previously, there was no centripetal force. When the plane banked, it gets a centripetal force, or rather, the horizontal component of the lift has become a centripetal force. Okay? So, what am I looking at here? Yeah, let's do some calculations. So we know F equals ma. But what is the acceleration here? It's centripetal. And I see, you have me saying centripetal now. It's centripetal acceleration. Do we have a formula for centripetal acceleration?
V squared R.
That's it. Now, do we have the F? Which of these forces is the F in this formula?
The Lx.
The Lx. So Lx equals 10,000. And the A, what's the formula for?
V squared over R.
V squared over
R.
R. Do we know the V?
No.
No. In fact, I forget, what are we looking for?
But we can
The force.
calculate the
Yeah, we're looking for it. We have a formula for V. What's our formula for V? Omega or. 10,000 over 1,000 is 10. Omega squared or squared. Do we have the or? We do. So that's 10 times 1,000 squared. Do we have the omega? No. What's the formula for omega? 2 pi over t. Do we have the t? 60. Now we can work out the centripetal force. Let's calculate it.
109.
Huh?
109.
Should I trust you?
Yeah.
Maybe I trust you. Maybe not. Oh. Where? See, I knew I shouldn't trust you. Okay. What's that? 109,662.
Yeah.
110 kilonewtons.
Exactly what I said.
Congratulations.
But you not trust me.
I know I do. Okay, write this one down, please.
Actually, today I won't go to school.
You didn't go to school. Then who am I talking to?
Actually,
Yes.
I went to the exam and then I missed the physics class. So I come here.
But this is physics class.
This is physics class.
So what do you mean you missed the physics class?
I don't want to miss the lesson.
Ah, so what class did you miss?
Nothing.
So what are you telling me?
She wanted to go home, but she stayed for the physics class.
Yeah.
So touched. Really? You're so sick, but you must go to physics. Not like Yusuf. I know he's not going to watch this video tonight, so we can say whatever we want about him.
What if he actually watches?
If he posts something, he'll watch. Okay. Do you have this? Now, what? No. When you're ready, what I want you to do next, you now have enough information to work out the L. I want you to work out the L.
It's one's birthday and it's Lee's birthday and his birthday.
Well, that's because Lee told me physics is his favourite subject.
Should we not know the angle of the cake to me?
Trust me. You have enough information to know the L. Look at me. Trust me. See? Trust. I see I'm going to have to work harder to earn your trust. Got an answer? Okay.
We're looking for LF.
Al. You know Alex. We just worked it out. Got an answer? Alright, let's have a look. So, Lx is 110,000. Ly is 10,000 G. Why?
Because it's equivalent to the weight.
Yeah, because the plane is only travelling in a circle. It is neither ascending nor descending. So then L is the square root of 110,000 squared plus whatever the heck that is. So let's see what we get. 110,000 squared plus 10,000 times 9.81 squared. Square root the answer. And what's that? 147 kilonewtons.
Yes.
I want you to appreciate what you're able to do here. By only knowing the time it takes to travel in one circle and the radius and mass of the plane, you're able to work out the force provided by the engines. Because the only information at the start were three things: the radius, the time, and the mass of the plane. And you're able to work out the force from the engines, 147 kilonewtons. Yes?
That's the force from
That's the L.
engine.
Yeah. That's the lift force provided by the engines. Yes. Continue. Okay. Right. Write or draw, please.
Swing.
Oh no, come on. Please. Please. You must know this verb. He'll show you. Look at him. Look at him. Look at him.
You know, in the park, there is a boy.
Ah, that's the noun. That's the noun. We want the verb. Yes. Yes.
Why
I
is so
believe you.
different?
Why is what so different?
Swing.
So different?
Yeah, the noun is different and the verb is different.
No, swing is the thing you sit on, and that, yeah.
Yeah, but
And
why
swing.
we
is
change?
Because it swings you.
They get it. It's English. English. What can I say? Okay. I'll let you try this one now. Because I think the next one... Ooh, yeah, next one's my favourite. So I'll let you try this one, and then I'll do the next one. Let's see if you can get this. What's that?
Object.
And what's that?
Make a boy.
Ah. Much better.
Why we need a mask? It's not me.
I don't know. Maybe you don't need it. Maybe you do.
Stephen, could you just clarify one thing a little bit? Earlier slide, it was written that frequency is equal to 2 hertz, and 2 orbits are completely in one second. Does it apply to every circle?
Yep.
Every circle.
Yep. And in fact, not only to circles. So if you say the frequency is 2, you just mean 2 cycles are complete. That cycle could be a circle, but that cycle could be anything. That's could be a wave, but it doesn't even have to be physics. You know, it could be like some kind of biological cycle where energy comes in, some process takes place, and something comes out. You know, so just generally speaking in English, the word frequency just means number of completed cycles per second. Yes.
When we get such a question, do we calculate the linear velocity or the angular velocity?
Yeah, the velocity it will be more precise in the exam, but the context here is, without mentioning the angle, we imply the linear velocity. Because our basic understanding of the word fast is through space, linear, you know. I should be more precise, perhaps. Alright, let's have a look at this. Can I look at this? So, V equals omega or. Do we know omega?
No.
No. Do we know or? Yeah, what's the or? 2. What's another formula for omega? 2 pi over t. Do we know the t?
No.
No. What's a formula for t? 1 over f. So this will be 4 pi f. And what's the f? 2. So this is 8 pi, which is 25.13 meters per second. Continue?
Yeah.
Okay. Oh no, this isn't the question I really like. I think the one I really like from the homework. Anyways, a ball rolls inside a sphere of radius 5 meters forming a circle of radius 4 meters. So all I want you to do is draw this. And let me see if you can draw it the right way.
Ball. Ball.
So,
The shape of the ball.
You know your shapes? Rectangle, triangle.
3D.
Yeah, 3D circle is a sphere. What's what?
where that?
Oh, no, don't. What's what? Rectangle?
No, I mean what? The list you.
Shapes. You know shapes? Circle, square, rectangle, triangle. I know, really? You know this, don't you? Or not?
No.
Get out your dictionary. Dictionary.
This is rectangle. Is it square?
Rectangle.
That's a rectangle.
Those are squares.
Squares.
Triangle.
Triangle.
Circle.
Circle.
Oh, shape.
That's what I said, isn't it? Yeah, shape. What did you think I said?
Shape.
Shape? Yes, okay. Shapes. So a sphere is the ball. Like a football. Yeah. Okay. Have you drawn that? Let's see. Good try. Did you draw it? Let's see.
Looks ugly.
That's okay?
This is the sphere, this is the ball, this is the top of the ball.
Oh, you're right, that is ugly. But I think it's okay. Anyone else draw it? Let's see. No, don't show her. Oh no, you can show me from here. I can see.
This is the radius of the circle and this is the radius. With the ball
Okay.
inside.
Everybody's kind of drawn this from the top, I think. Are you looking at the top or the side?
The
side.
Are you looking at the top or the side?
So.
I cut it.
No, I'm looking from the bottom.
Looking for the inside.
Continue it. Right, so this is what I'm picturing. I think you might have it, but this is what I'm picturing. Here is the sphere. It's a sphere on the ground. And the radius here is 5. And then inside it there's a ball, and the ball is rolling around inside of it. And the radius here is 4. Yeah? And my question is,
What I thought of is the ball has a radius of 1 meter. So when it's spinning inside, so when it spins like this, it is 4 meters.
yeah, that's possible, but the way the gravity is acting means that it couldn't do that. It has to be spinning around in a horizontal circle.
Unless it's fast enough.
How's the ball's radius?
If this one is 1 meter, then wherever it spins around the sphere,
You took this to be a radius 1 meter.
yeah.
Okay. Anyway, this is what it is. Let's have a look at it. So, what forces are acting on the ball here? Its mass is m. Well, mg, of course. And what other force is acting on it? I told you, I made it so clear earlier. No, don't say that. What is the other force acting on it?
Mg.
The banking force.
Anybody?
The force of the spin.
That's nearly the same thing as
The
what they're
force of the
saying.
movement.
No. That force doesn't exist. No. Reaction. Reaction from the surface. You know, it's on the surface. Mg, reaction. Yeah? Now, this can be resolved horizontally and vertically, or y and or x. we know that or y, what should that equal? mg. Yes? We also know or x is a centripetal force. I'll write like this here. Okay? Now, I'll say or x, that's equal to, what's our formula? MA. But what's our formula for A? V squared over or. Now, what is the radius here?
4.
4.
That's why. Never mind.
It's okay? Yeah. Is that okay so far? Yeah. Okay. And we still have or y equals mg. Got that? Yeah. Now, watch this trick. This angle here is theta. What does tan theta equal? Or y over, come on, you know this, or y over or x, right? What's or y? mg, and or x? mv squared over 4. So the m's cancel, and you're left with 4g over v squared. But I can draw a triangle here, watch. How big is the base?
4.
4. The hypotenuse? The hypotenuse? 5. Because it's the radius of the sphere. And from Pythagoras this is 3. What is the tan of this theta? Tan theta equals 3 over 4. So I can say 16g equals 3v squared by cross multiplying. Bring the 4 up and the v squared up. So then what does v equal? Square root 16g over 3.
What is that for before the 3/4? Yeah.
4g?
4g.
Yeah. 16 times g divided by 3, square root the answer. 7.23.
Why is it 5 and 3?
Are you happy with this being 5?
No.
Here to here is the radius of the sphere.
Yes.
And I told you the radius of the sphere is 5.
Why did you take it to the center of?
I don't understand.
Why did you make the triangle to the center of the circle?
Here's the sphere.
Yeah.
Here's the mass.
Yeah.
This is mg.
Okay.
And the or is perpendicular.
Yes.
And you know from basic circle geometry that points to the center of the circle.
Yes.
So if I draw a triangle here, I can calculate the angle of the or. I know that this is 5 and we know that this is 4, and so we can know that this is 3.
But why you know the point in the center? The point far.
How do I know it's in the center? Because I said that it moves forming a circle of radius 4. So it's the only way. Do you know, I can't... If I have it not at the center, and this is 4, then it comes outside the sphere. Yes.
Did you get what I drew?
Not really.
The circle was 1 diameter.
1 meter?
Yeah.
Which circle? The small
The
one?
small one.
Yeah.
Then it would be spinning in the middle.
I suppose.
Would that still make it a 4? Would that still make the big
No,
4?
because the radius of the small sphere we don't consider.
Yeah, but why?
4.
What do you mean why 4? Say it in the question. A ball rolls inside a sphere of radius 5 meters,
Because
forming a circle of radius 4 meters.
it's like this, because the sphere goes, it grows, so it's like in the lower part.
Yes.
Because it has a smaller diameter, because the sphere is made up of many circles, yeah?
Yes,
So the middle of the sphere is like 5, the radius is 5 because it's the biggest, and then it gets...
Yeah, the biggest it can be is 5, so a 4 meter circle formed has to be below.
Yeah.
What? What's wrong?
I'm imagining.
Maybe this is the problem. Don't use your imagination.
Could you...
I'll go back yet.
Okay.
Notice how the only thing I had to tell you was the radius of the sphere and the circle. I didn't even have to tell you the mass of the ball. And you could still work out the speed.
Or F is equal to
F circ, as in circular force. Centripetal force, or centripetal if you prefer.
How could we practice questions like this?
Don't
Do you
worry.
have a website?
I have homework questions for you to do.
No, other than that, like we finish homework and then...
I sent you those links, didn't I? I have more questions. If you need them, you can email me. I'll send you the link to a PDF that has questions and solutions on circular motion. Now they start off simple, but they get quite hard. So you don't need to do the whole chapter, but you can do enough of it to feel comfortable with it.
So if we're good at this worksheet, then we'll do so.
For what? Circle?
For example, yeah.
This is maximum difficulty in the exam, this question, yeah. And most of the time it won't be as difficult as this. It'd be more like the plane example I gave you. So this is maximum difficulty. Now I can't imagine this in the question in the exam because it is a bit like the plane question. But I don't think it should be harder than this.
Send me your email now.
For what?
For the extra questions. So that I won't forget later.
Please have mercy on me. Continue?
What should I write
No.
in the email?
Dear Steve.
Right. Dear trustworthy Stephen, who I trust, I'm trusting you to send me the circle motion questions. Yours trustfully, Faisal. Okay, continue. Andrew?
no.
Not yet. Is that a Pokemon? Is it? Let me see. What the heck? Weird. Okay. I think we're just waiting for you, Andrew. And you know the rule. We will leave one man behind. I'll give you one coffee sip. Continuing. You'll have to grab it from the video, okay? Right. Tasty. We have lots of circle questions here. And number 6, if you felt they were too easy, don't worry, number 6 is very difficult. And I warn you in advance, it's very difficult. Okay. Question 1 to 5. 1 to 5 are all exam style questions. Number 6 is way too difficult for the exam, but it's still a very good question to do to test and strengthen your understanding of circular motion. But for exam purposes, you should be able to do 1 to 5 without trouble. And you can start them now for about, that clock's a little bit slow. Oh yeah, about 15 minutes. So see how many you can get done now. The more done now means the less to do at home. Okay.
This is for...
Our next physics class. No, because my next physics class will be 2 hours. Correct?
After the 100.
No, not 2. The next physics class is 2 hours, correct?
No.
One.
That's more, yes, we have 2
Tomorrow.
hours this week.
I don't know.
Oh, that's it.
On
Oh, well-
Thursday, because all the classes will be cancelled.
Oh, so we only have 1 more hour of physics on Friday.
Tomorrow and on Friday. Friday we have.
How
the
much do we
exam.
have tomorrow?
1
1 hour. And on Friday?
We have the exam.
How much time do we have?
I think 1 hour.
Right, so that is the exam. But tomorrow we have 1 hour.
Yeah.
So it's for tomorrow.
Um,
Because we'll be on the test. Like I said, everything up to 5 minutes before the test will be on the test.
Are we going to cover more tomorrow?
Look deep inside you. What do you think the answer is?
No.
No, look deeper. What do you think the answer is? Yes, you are right. Okay, I need to close this now. You can open it on Moodle. Try to do as many as you can now.